experience wave particle duality. The argument being that the wave mode of a quanta of energy observes statistical behavior and as such can be measured that way with interference patterns through the double slit experiment. Reality of it is that as a particle is quantum energy, especially discrete quanta of energy where it's not part of a larger system, and there is a threshold at which behavior starts to change. Like, do protons exhibit wave particle duality? Do neutrinos exhibit wave particle duality? Photons, electrons do. It has to do with how they propagate through space, or how their translational form of energy is propagated on a vector through space. It's a tensor. As I've said before, what is the edge of a cloud? The fact that the cloud is not just, the cloud represents the particle here, but the moisture in the air around the cloud represents the field or total local influence in cubic space of the quanta of energy, photon or electron. And these particles propagate through space, translate through space, using a stepped leader dynamic, where one description being that they explore all paths such that the minima path through space is traversed ultimately. Why would that be? It's because as the particle translates through space, it is that space. And it has a leading edge and a trailing edge through which its existence is manifest as a connected part of the local cubic space in which it is participating. So, given that it has this behavior of exploring via a stepped leader mechanism, these paths, when going through slits, will diverge and reconverge. And when this goes back to the previous things, the classification of different interactions, is that you have moments, not moments, I won't call moments, they're called steps in the step leader process, where there are two routes to get to the same outside of the double slit, and thus the step leader's effect interferes with itself statistically in a wave front pattern, thus coalescing, making two step leaders when they coalesce, the probability of both. If you're going to say probability is real, it isn't, but it's just a measure of the behavior in aggregate, solely in aggregate, is when these different paths, step leader branches, converge, leading to a more probabilistic outcome of the energy being delivered to a specific part of the target, thus generating a wave interference pattern. It's actually, whereas you think of a wave as being a smooth curve, it's actually much more lightning bolt structure, very angular branching patterns going in the direction where in the direction of motion, the vector, the tensor, the branches tend to be extending, and in the trailing edge they tend to be collapsing or filling. It's like the lightning stroke, and then a side branch dumps its energy into that branch where the stroke happened. Whereas without the slit, it's simply the first place that touches, which is logically going to be at the leading edge of that photon's step leader sear. First touches the detector, the screen, is where all of them are most likely to occur, given no other perturbation within the space through which the quanta of energy is traveling. Now, the reason why heavier particles would tend to lose this is because of their aggregate behavior is more autistic. It's very involved in actualizing its own structure, such that the step leader effect that it does have is much more minimized as compared to lighter quanta such as electrons, photons. And I don't know the answer to this question coming up. Has anybody done a double slit experiment with neutrinos? Is it even possible? Since it flies through everything. And that may be where it doesn't matter, so it doesn't call yourself a physicist and you believe almost as a religious belief, a religious tenet or premise or axiom, that the universe is probabilistic, you're probably an engineer. That mentality is better for an engineer. It's better for an engineer. Because engineers work in terms of things that are functional to a human purpose, as opposed to being how the universe actually works. One's based in the other, but the truth underlying it is that of a physicist's truth, not of an engineer's truth. An engineer's truth is solving a technical problem. Or maybe creating one in some cases. But, we're not going to get into that right here. So, and it's interesting when you think about it, like a photon of light generated within a star and the walk it makes from its fusion site within the core to the edge of this photosphere where it is emitted. That walk is modeled well, in my mind. It's very reinforcing of the concept of the step leader, and the fact that there are a massive number of step leaders interfering with each other. So the photons are basically bouncing each other all over the place. Additionally, the atoms are absorbing them and re-emitting them as they emerge. But it's very much this effort to... It's pathfinding, right? It's pathfinding, it's eddy currents that interfere with those paths, and it's mindless. Where you have... It's an interesting question. I have to go to memory banks here. There's fusion in the center of a star generating photons. There's a photon pressure. I'm imagining that the photon pressure has some governance on the rate of fusion. Because it's interesting. Because it's a runaway reaction. Yeah, it has to. Because it's going to create heat. The heat is going to cause the atoms to push apart, which is going to change their proximity, which is going to, in turn, govern the rate of fusion. Okay, that makes sense. I don't think I've actually ran down that path before. Or maybe I have. Things are just occurring to me, juggling, double checking, cross checking, put it that way. I wonder if there's a point at which, though, I'm sure that it can happen in an eddy, or you can have an overabundance of photons. Is that possible? What would an overabundance even mean? Or black? Well, black would just increase the rate of fusion, so it would solve its own problem. Too many. Okay, there's a point at which there could be too many. It would take a lot. turn a photon into an electron. It should be possible. You could even do ridiculous things like turn electrons into protons. Could you do that? Yes, the charge would split, change. Or would it be not a proton, it would be what do they call it? Antiproton. Electron. That's confusing, right? Name. It's called an antiproton from the I hate anti, because it is an anti. It's just a different charge. It's like threads of a screw. Right-handed, left-handed. When they get together, they unscrew each other. Like, when I think of antimatter, I hate the term antimatter, because to me it implies anti-mass, which is nonsense. There's no such thing as anti-mass. Complementary charges. I don't even want to say opposite. Matter and antimatter. We've talked about that before. The reason that there's a preponderance of whatever we want to call matter. Somebody else might call it antimatter if you were from here. Clockwise is the spin of the universe. The universe has a spin, and the spin dictates the charge. The spin of the universe dictates the predominant charge within a region. It is possible for the spin in different parts of the universe to be different, but it would require significant spatial gaps between areas of different mass charges. Does space itself have a charge? Which I guess I'm sort of saying that, aren't I? Space itself has a charge. If the universe has a charge, space itself has a charge. It's just that it's massively aggregate, and as far as we can measure, it becomes zero because it's the same all around us. And it doesn't affect anything except us having matter versus antimatter. So we do observe the charge solely through the fact that we have matter. But it's like this is as profound an insight as gravity, where hey, something pulled that down. Why? It's sort of like charge is because it's something that's all around us, right? Gravity is all around us. Come up with this idea. Matter, antimatter, because the universe has a spin, therefore a charge, therefore matter within this region of space of the universe will adopt in general that same charge. It's kind of the same thing if you think about it. It's as obvious as gravity is now. When Newton discovered it or realized it, kind of the same idea, realizing that we have matter, not antimatter, is because the universe itself has this charge, which is due to a spin, which is just everywhere, and we just don't notice it because we are here. I know I'm repeating myself, but I'm just trying to blow holes in my own thinking. And I'm trying to say, is it as profound as you really think, or is it just dumb? Well, if someone were to tell you they discovered gravity yesterday, you go, duh, because it's been a well-known phenomenon. So, in 100 years, this is a duh moment, but now, is it profound? I don't know. If it's right, if it's meaningful, if it furthers the conversation in general, I suppose. Forgive me for indulging in this. I do want to have contributed something significant to the conversation. It's the whole reason I'm creating these videos. So please tolerate me, or thank you for tolerating me. Maybe that's a better way to put it. Or hopefully you're getting something out of this, enjoying it. I'm almost home, so since I'm rambling, I'm gonna cut this one off.